Hello, in this video we will introduce nonparametric statistics and one kind of test called sun test with paired observations. So nonparametric statistics is a statistical distribution-free statistics because in many statistical tests we assume that the data comes from normally distributed data, or at least a little diffusion from normal distribution. But sometimes this assumption cannot be met, and we can use alternative statistics called nonparametric statistics to do such kinds of tests. And the nonparametric statistics usually based on the data, ordered data. And one kind of test called sun test, we arrange the data from the lowest to the highest, for example, and test if the median value is equal to assumed value. And we usually transform all the data with a plus sign and a minus sign if the data are less than this assumed median value. And the sun test can also be used for the paired observations. So here we observe paired values for one subject, and we take both of values and using the difference between these two. So for example, D1 minus D0, if it is positive or it's negative, then we set plus or negative sign for this value. And the assumption here, we will test, for example, the null hypothesis is the population median difference equal to assumed value. So next we will show an example. So taxi company trying to decide whether the use of radial tires instead of regular belted tires improve fuel economy. So 16 cars are equipped with radial tires and driven on a prescribed test course. And without changing driver, you use the same driver, the same cars, and then equipped with the regular belt tires. Then drive on again on a test course. Then we get the data for the gasoline consumption for both driving on with the regular tires and the new radial tires. So the question is, can we conclude at 0.05 level of significance that cars equipped with radial tires obtain better fuel economy than those equipped with regular belt tires? So here is the table for the data. So there are 16 observations from both radial tires and belt tires. So the solution is, first, we will let the mu1 hat and the mu2 hat represent the median kilometers per liter for cars equipped with radial and belt tires. Then we form the null hypothesis is mu1 hat minus mu2 hat equals 0. So this is the null hypothesis which we assume there is no effect for radial tires, and these two median values will be equal. And alternative hypothesis is mu1 hat minus mu2 hat larger than 0. So mu1 hat here is for new radial tires, and this is for the regular tires. So we assume so that in the actual alternative hypothesis, we will reject null hypothesis and we'll get the conclusion that the new tires will have better performance on consumption than mu2. So here we set significance level 0.05. So in the sun test, if the null hypothesis is the same, so which means the median value on both sides of the median value will be 50% and 50%. So which means the data will come from a binomial variable x. Here x, which means the positive value, for example, between these two median. So So the binomial variable x comes from a positive value is 0.5. So, which means on both sides of the median value, here median value is 0, right? So the difference of these two trials, the median value is 0. And on both sides of the 0 will have 50% of the probability, right? I'll say there will be approximately equal observations for this ranked data on both sides of 0. If we check the difference for all the tiles, 16 tiles. So now, after replacing each positive difference by a plus sign and negative with a minus sign symbol, then we will discuss the two zero difference. We obtain in total 14 data. So plus minus plus minus. So plus means there is larger than 0, right? Plus, and minus is less than 0. And the total n equals 14 observations and x equals 11. So x here is a positive value, 11 positive value from this total 14. So here is like a binomial trial with n equals 14, and we get 11 positive value. If we assume that this binomial trial, Bernoulli trial with the probability 0.5 in each trial. And calculation of the binomial can be approximated with the normal distribution here. So we will transform binomial value to a z value in the standard normal distribution. So here we use the 10.5 because we assume this is a continuous value. So 11 will be transformed as 10.5 and minus 7, because 7 is the median value. If in the 14 times trial there are 7, if we assume there are 50% for both positive and negative. So here is a positive variable x. So we assume that the mean value in the null hypothesis for the positive is 7. So 10.5 minus 7 and divided by the square root is standard deviation. So it's my binomial standard deviation is NPQ. Here P is 0.5 and Q equals 1 minus P. So this transformed z value is 1.87. And the probability of x larger than 11 is approximately equal to the probability of z larger than 1.87 in a standard normal distribution. So here the probability of a binomial x larger than 11 equal to probability of z larger than 1.87 in a standard normal distribution. And this probability about 0.03, because this is less than 0.05. So this is a p-value. So we will reject H0 and in favor of the H1 alternative hypothesis that we can conclude on average radio ties do improve fuel economy in this example. Thanks for watching.